You can get full marks on these type of decay problems, and all it takes is 5 minutes to learn the formula and how to use it. So the charge of a battery after T hours is given as P. P is just this exponential function for decay. The question says, what is the half-life of the battery? To figure out the half-life, you need to understand the formula for decay. So P is equal to P0 e to the negative RT. To find the half-life, all we need to do is replace P with 1/2 of P0 and then solve for T. So in our question, what is P0? P0 is 100. So let's replace P with 1/2 of 100, which is 50. So 50 is equal to 100 e to the negative 0.08 t. Step 2 is to just solve for t. So let's divide out 100. So we get 0.5 on the left side. On the right side, we're left with e to the negative 0.08 t. Now we can take the ln of both sides and get rid of this e term and bring that negative 0.08 t term down from the exponent. So ln of 0.5 on the left is equal to ln e to the negative 0.8 t on the right. Ln of 0.5 stays the same on the left side here. And then this cancels, and we bring down this negative 0.08 t. Now we can just directly solve for t with easy algebra. So t is equal to ln of 0.5 divided by negative 0.08, which is equal to 8.66, and this is 8.66 hours. Okay, moving on to questions 2 and 3. We have find the charge remaining after 5 hours for question 2. That's super easy. All we do is take P here, and P gives us the charge, so we just plug in 5 for T, and we get 67%. So the charge after 5 hours is 67%. Very easy. The third question is a little different. So at what rate is the change decreasing by after 5 hours? Notice the difference here. We have find the charge remaining after 5 hours. So it's referring to the initial formula we're given. This one says at what rate is the change decreasing? When we talk about rates and need to find at what rate something is decreasing, we're referring to the derivative. So P prime is equal to the derivative of 100 e to the negative 0.08 t. So to take this derivative, we just take the derivative of e to the x and do the chain rule and account for this inner function, negative 0.08 t. So the derivative of e to the x is just e to the x, so we write that down as the exact same thing. Now we account for the inner function. This one right here, what's the derivative of negative 0.08 t? Well, that's just negative 0.08. So this derivative that we got from P describes the rate of change, but we need to find it after 5 hours. So P prime, we're going to plug in 5. We get 100 e to the negative 0.08, place t with 5, and we have times negative 0.08. So from the last question, we already found out that this term right here is equal to 67%. So we get 67% times negative 0.08. So our final answer for P prime at 5 hours is equal to negative 5.36. Now, what does that mean? That's negative 5.36% per hour. Remember, this is a rate. We're not just getting the percent here. We're asked what rate is the change decreasing after 5 hours? And since we took the derivative, we now have a rate, and that rate is percentage per hour. So the final answer is negative 5.36% per hour.